In this video, I'm going to sum up all of the different ways that logs and exponential equations can be solved and how you can tell which method to use. Now, something I need to cover very early on is this idea of what you see in the blue ink and what you see in the white ink. So with the blue ink, this is talking about log equations. And you can tell that you're working with a log equation because you will either see log or ln for natural log. And this log can have any given base except for e. That's what the natural log is for. Now it's a little different when you're working with exponential equations. You know that you have an exponential equation when you have a base with a variable in the exponent. So this variable in the exponent is how you tell that you're working with an exponential equation. So let's get into the different ways to solve log equations. You can see there's the one-to-one property and rewriting the log equation in exponential form. Now when you start solving log equations, or when we start looking at log equations on the next slide, you're going to have to be able to tell, do you use the one-to-one property or do you rewrite it in exponential form? And there's a very easy way you can tell. You will use the one-to-one property if all terms are logs or natural logs. And that's it. Everything is inside an argument. You will want to use the rewriting in exponential form strategy if there's a constant outside of a log. So here you can see it. Any constant is outside of all the logs. So those are your clues. And again, we will take a look at some examples on the next page. So now to move on to exponential equations, you will want to solve the exponential equations using the one-to-one property if you can make like bases. So if you see that both bases in an exponential equation can be rewritten as a base 2 or a base 3, 4, 5, or 6, or maybe even 7, then you should rewrite them at different bases, and that way you can eventually set the exponents equal to each other. How you will know you will be rewriting in exponential form is if you cannot make like bases. Like bases. If you cannot make like bases, and usually, if you see an e in an equation as one base and any other number, you will be rewriting an exponential into log form. So we will go over to the next slide, and I'm going to just let it sit for maybe 10 seconds, give you a chance to pause the video, and you're going to see 8 different equations. And I want you to try your best to figure out which property you'll use, either one-to-one property or rewriting, and that's for either one, logs or exponentials. So I'll flip over to the other slide now and give you a chance to check it out. Okay, now that you've had a chance to pause and hopefully work through which method you would use, I see with this very first one, I'm just going to go through them in sequential order, 1, 2, so on. So in this very first example here, I see e to some exponent equals 4. Now, I cannot easily answer the question, what power of e gives me 4? I have no idea. And nor can I answer the question, what power of 4 gives me e? So I can't rewrite either of these bases in terms of the other. So I know here I will need to, this is an exponential equation, and I will need to rewrite this in log form in order to solve this equation. The next one, number 2, I can see here that I have a log base 2 of x and a log base 2 of x plus 1, and on the other side of the equation I just have this lonely 1, this constant. It's not inside a log base 2. That's my clue. This one will eventually be rewrite, I want to say this is a log first, so this is a log equation, and this needs to be rewritten in exponential form. For number 3, I see a log base 10 of x and a log base 10 of x squared minus 6. And that's it. This x is inside of a log, this x squared minus 6 is all inside a log. There are no constants just floating around outside of any logs here. So this one, this log equation, I'll get to use the 1-to-1 property. Let's see, in this next example, example 4, I see that if I have the base 4 being raised to the 2x, and on the other side of the equal sign I have the base 8 being raised to the 4 minus 3x. And it turns out that I can rewrite 4 as a base of 2. This would be 2 squared, if you just look what's inside the parentheses. And over here with 8, I can rewrite 8 as a power of 2 cubed. Now these exponents on the outside would still come along for the ride. We can't just get rid of them. But I was able to make the same base, so that means I can use the 1-to-1 property and eventually set the exponents equal to each other. So this was exponential, and we can use the 1-to-1 property here. And really quick for these last 4 over here, 5, 6, 7, 8, I'm able to rewrite 1/25 as a base of 5, and this is already a base of 5. So since I can get the same base on both sides, I can use the 1-to-1 property for exponentials. I can eventually set the exponents equal to each other. Since over here with these logs, I don't have any constants outside of a log. Everything is inside. Everything is in an argument. 1, that's a constant inside of a log. 3, that's a constant inside a log. X, it's inside a log. Everything is inside a log. So I can use the 1-to-1 property. And I realized I didn't mention it over here with this example, but the 1-to-1 property is what allows you in the log examples to, what I like to say, chop the logs from both sides, aka cancel the logs from both sides. And you can only cancel the logs if you have one log on each side. All right, back to number 7. This one required a little bit of work here. I needed to isolate the exponential piece, that's the base and the exponent. So I had to subtract 10 to realize that 2 to the 4x minus 3 equals 5. And I can't turn 5 into a base of 2. I don't know what power of 2 gives me 5, so I have to rewrite this in log form. And lastly down here, number 8, this log minus 3 equals 0. This, if you isolate the log, you can see it a little bit easier by adding 3 to both sides. And now I can see I have a log on one side and a constant just kind of hanging out, not inside of a log, on the other. You could have just as easily looked at the original equation here. I have a log, and this constant -3 is not in the log. It's not in any log. So we would have to rewrite this into exponential form. But in order to actually rewrite it in exponential form, this plus 3 to both sides needed to happen. All right, well, I hope that's helpful. Oh, I do have one more bit of information for you. You can see now on screen that there are some answers for these actual problems. I urge you to go ahead and try solving these yourself. Also, you may have noticed I did not leave an answer for number 2. I have another video explaining how to solve log equations when you need to combine or condense 2 logs before actually solving. So I urge you to check out that other video to see how this one works.